Now, remember that the program that loops forever, the A program that loops forever is while 0 equals 0, do skip. Now, I think it's a little bit easier for me to write this down if I just call this little code fragment loop. And we proved in class a theorem that said that loops forever. In other words, for every s and s prime, if you evaluate loop in state s, it does not evaluate in the big step semantics for states to s prime. So this, I'm going to write a not in front of this. Or I could, maybe it's easier to write this in this way. I say like, not. So we prove this thing goes forever. Now, consider the program that is loop or x gets the value of 1. Now, what does this evaluate to? Well, what does a derivation for this look like? What are the possible big step semantics for statement derivations? Well, we've got loop or x gets the value of 1 has to evaluate, in state s, I'm sorry. In state s has to evaluate to s where x gets the value of 1 because x gets the value of 1 in state s evaluates to s where x gets the value of, is updated. The state function s is updated so that the variable x gets to the map to the value of 1. But remember, based on this theorem up here, that there is no way to evaluate the loop program and get anywhere. So that means that this is the OR 2 rule, and so this is the OR 2. BSS rule, but they're OR 1 BSS does not apply. because of this theorem up here. Right here. Oops. This theorem here. No matter which S and S prime I pick, loop in state S does not evaluate to S prime. So this is a bit weird because what it means is that the semantics of the semantics themselves are specifying of how rules are applied, are specifying that here, that somehow the semantics or the evaluation mechanism implementing these semantics has to magically be able to tell whether a piece of code terminates or not. Whether a code fragment terminates or not. So this means that, or this is called angelic nondeterminism. And it's because we don't know how to implement it. We would have to solve the halting problem. In a Turing complete language. Now, I think I'm gonna stop here and get another recording going.